Today we'll be learning how to solve equations. So in general, the quadratic equation in standard form is represented by ax squared plus bx plus c equals 0. For a quadratic, we have multiple ways to solve this equation. The first way is factoring, which is not always possible. The second way is the quadratic formula, which takes a little bit longer, but does always work. And then we could graph or complete the square to solve the equation. But generally, we're going to either factor or use the quadratic formula, because graphing isn't very accurate. So, what would happen if we tried to solve the equation x squared minus 2x plus 5 equals 0? Okay, we can't factor that, so we go and use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we plug in the a, b, and c, we would eventually get it down to x is equal to 2 plus or minus the square root of negative 16 over 2. Okay. And in grade 11, we would stop there and we would say that there's no real roots to that equation. Okay. And that is still true. There are no real roots, but there are something called complex roots. So to deal with complex roots, we first have to define the imaginary number I. So I is equal to the square root of negative 1, and that's by definition. We call this the imaginary unit. Okay. Also note that if you squared both sides to get I squared, then that would get rid of the square root, and I squared would equal negative 1. So a complex number is a number that has both a real part, which is the numbers we're used to dealing with, and it can also have an imaginary part. So a complex number would be a plus bi, where a is the real part and bi is the imaginary part. So an example would be 5 plus 2i would be a complex number, or 6i would be a complex number. So how does that help us with our quadratic? Well, in grade 11, you guys did learn how to break up radicals. So we can break this radical up as well. So the 2 is going to stay the same. It's going to stay all over 2. But that's 16. I'm going to break it up into negative 1 times 16. And when I have two things that are multiplied together under a square root, I can just take the square root of each part. So I can take the square root of the negative 1, and I can take the square root of the 16. And this helps us because we know now that the square root of negative 1 is actually I. And we already know what the square root of 16 is. The square root of 16 is 4. So what we actually have there is 2 plus or minus 4i all over 2. And of course that can be reduced because everything has a factor of 2 in it. So we can divide a 2 out of every single term. And we would just be left with 1 plus or minus 2i. That is actually the answer to our equation. Okay? It's a complex number, but it is still an answer. So we can now actually go further than we did in grade 11 because we can simplify things sometimes when they have negative roots. So here's our first example. It's asking us to solve this quadratic equation. So we're going to start by using the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And when we simplify under the square root, we get negative 23 all over 6. Okay. And negative 23, right, that can be written as negative 1 times 23. And so we're going to take the square root of each part of that. Square root of 23 is going to be root 23. And the square root of negative 1 is I. So our answer to this equation is x is equal to 5, negative 5, plus or minus the square root of 23i all over 6. Now we're going to get into solving polynomial equations. So to solve polynomial equations, we're actually going to use what we've learned up till now in the course, because to solve an equation, you do want it in factored form. So the first step would be getting it into factored form with one side equaling 0. So here's our first equation. They already put it in factored form for us, and they're asking us to solve for both real and complex roots. So because it's already in factored form, what we're really going to do is we're just going to set each bracket equal to 0, and that would get us our roots. You don't need to show that 0 step, because you can just think about what would make each bracket 0. So here x would equal negative 3 over 5, and for this one, x would equal negative 1. So the solutions to that equation are x equals negative 1, negative 3/5, and positive 6. We do generally list our solutions in order. Here's our next example. This time it's not given to us already in factored form, so we are going to have to start by factoring it. Okay, it's 3 terms, but it's not a trinomial, so we can't use decomposition for it. We can't group it, so we're going to have to use the factor theorem and synthetic division. So I'm going to let f at x equal the cubic, and then we have to find something that makes f at x equal to 0. And if you tried a bunch of things, you would eventually get that f at 5 equals 0, which means that x minus 5 is a factor by the factor theorem. Okay, so we can divide that out. So 5 is going to go on the outside. We have a coefficient of 1. We don't have an x squared coefficient, so I'm going to put a 0 in. We have a negative 27, and we have a 10. So do our synthetic division by bringing down the 1, multiply by 5, add, multiply by 5, add, multiply by 5, add. And we get that f at x is now equal to x minus 5, and then here we have 1x squared plus 5x minus 2. And we can factor that quadratic. Are there two numbers that multiply to negative 2 and add to 5? No, there's not, so we're actually going to have to use the quadratic formula there. So I'm just going to set this back equal to 0, because we need it equal to 0 in order to solve. From the first bracket there, we can get our answer of x equals 5. And then to solve the second bracket, we need to use the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we work that out, we will get that there is a root 33, and it's all over 2. And that can't be reduced at all, so we just have our two answers of 5 and negative 5 plus or minus the square root of 33 over 2. So that's actually 3 different answers. But there are our solutions. So for question C here, our first step is going to be to move that 32 over. Because remember, when we're solving, we want it equal to 0. Okay, so now we have a quintic function, degree 5. If we had to do the factor theorem, we'd have to do it quite a few times. So let's see if there's another way to do it. There are 4 terms, so we can try factor by grouping. So if we look at the first 2 terms there, we could pull out an x squared. and we'd be left with x cubed plus 8. And out of the next two, we could pull out a negative 4, and we'd be left with an x cubed plus 8. Okay, so factor by grouping does work here, because we do end up with that common bracket that we can now pull out. And we get one bracket that's x cubed plus 8, and one bracket that is x squared minus 4. Each of those brackets can actually still be factored, right? Because x cubed plus 8, that's a sum of cubes. So remember, we cube root each of these. So it was a squared, b squared. And then same sign, opposite sign, always positive. So that's that sum of cubes. And then this one here is a difference of squares. So it will also factor into two different brackets. Taking the square root of the first term, square root of the last term. One gets a plus, one gets a minus. And then we check this trinomial and we can't factor it. So we're going to end up having to use quadratic formula there. So the other brackets, we get solutions of x equals negative 2, x equals negative 2, and x equals 2. So the negative 2 will only end up writing once in the final solution, but it does actually appear twice as a solution. And then for this one, we're going to have to do quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And when we simplify inside that square root, we get that it is the square root of negative 12. And the square root of negative 12 we can split up into the square root of negative 1 times the square root of 4 times the square root of 3. Because 1 times 4 times 3 would give us the 12. And then it's all over 2. So simplifying that a little bit more still, square root of negative 1 is I. And I don't care if you put the I at the beginning or the end, it doesn't really matter. Square root of 4 is 2. And the square root of 3 is root 3. So everything has a factor of 2 in it, so we are going to reduce that. And we get an answer of 1 plus or minus I root 3 as the answer to our quadratic. So the solutions to this were x equals plus or minus 2 and 1 plus or minus root 3i. So that is our final answer. So once again, in your final answer, make sure that you go all the way back and you make sure that you got the answers from the brackets. If something happens to show up twice, we only write it once. You'll notice that we only wrote minus 2 once in there. And then if it's the quadratic formula, you just need to simplify. And if there's a negative under the square root, really that negative under the root just turns into an I that we pulled out front. So for more examples of solving, then you can go to the next video.